Section 1 and 2. Okay, we're looking at measuring and constructing segments. Our essential question, how can you measure and construct a line segment? So our first thing is the ruler postulate. Postulate is just a rule that's taken without proof. Okay, so this is just something that we state out and accept. So we have a couple different things here. The points on a line can be matched 1-to-1 with real numbers. That's what you do if you make a number line. You all probably did this in like first grade. The real number that corresponds to a point is the coordinate of a point. You're probably familiar with the coordinate plane. You have 2 points there that are separated by a comma. Well, if you have a number line, that one number is the coordinate. You have 2 in the coordinate plane because you have 2 number lines. Then the distance between points A and B is written as AB, nothing over it. Okay, that's how we know it's the distance of the line segment because there's nothing over it, is the absolute value difference of the coordinates of A and B. Difference, remember, is subtraction. Absolute value means it's always going to be positive. So if we were looking at this, if we have 6 here and 10 here, most of us would just do 10 minus 6 to get that distance is 4, and I don't need to worry about the absolute value. What this is saying is if I do the absolute value, then if I put them in the wrong order, it doesn't matter, I'm still getting 4. So the distance should always be a positive number. Congruent segments are line segments that have the same length. So lengths are equal. AB is equal to CD. Segments are congruent. AB is congruent to CD. Okay, so our congruent symbol is an equal sign with a tilde over it or a squiggly line over it. Okay, and if you look at these lines here, it's a little hard to tell. There's a dash on each one of those. That's how we mark congruence. So if I had a different line there that was a different length, I would mark it with 2 dashes instead of 1 dash. Okay, so everything with 2 dashes would be equal, everything with 1 dash would be equal. Then we have the segment addition postulate. Okay, the addition postulates we use a lot as we go through the year. The segment addition postulate I will refer to as SAP. Right, for segment addition postulate, you're welcome to do the same. This says if B is between A and C, then AB plus BC is equal to AC. And if AB plus BC equals AC, then B is between A and C. Easier way to probably think of this, 2 points, 2 parts add up to the whole. Okay? Your addition postulates are always adding 2 smaller parts and getting 1 large part. So AB and BC make the whole thing that is AC. That is our segment addition postulate. Turning the page, we have some examples of what our problems will look like here. So example 1, use the diagram to find KL. Okay. I have 18 here, or no, 15 there, 15 and 38. So I just subtract them. I'm doing 38 minus 15, and I'm getting 23 as my answer. Example 2, in the diagrams, point A, D, F, C, and B are collinear. So all those points are on the same line. And then they tell me some certain things. AB is 32, AF is 14, FC is 5, AD and DF are equal. All right, and they want me to find the indicated lengths. Depending on how comfortable you are with this, some of you can just look at this and see this. But a good idea is to mark things out. AD and DF are equal. So these 2 things are the same length. All right. AB, that's my whole length here. That's 32. AF, this length here, right, is 14. FC here is 5. So when they ask me AD, I can look and say, well, AF is 14, and these two things are equal. So AD is 7, 14 divided by 2. DC, I have this is 7 because AD is 7, plus 5. So add those together, I get 12. Okay. FB, now I could find CB and then add these two together. I can do that. But I also know this whole thing is 13 and this is 14. So FB would be 32 minus 14, and that gives me 18 as my answer. And there's several ways you could do these depending on how you think of it. But those should still be your answers. Example 3. Plot the given points in the coordinate plane that determine whether J, K, and LM are congruent. Okay, so this is a line, and this is a line. All right, so I'm plotting each of those as lines. So this is my 0, 0. So I go over 1, 2, 3, and up 1, 2, 3, 4 for J. K, I'm coming over 1, 2, and up 1, 2, 3, 4. So this is K. And then L, come over 1 and up 1, 2, 3. And M over 1 and down 1, 2. Alright, so that's LM. If I count those, for both of those, I'm going to get 5. So yes, they are congruent because they are the same length. It works nice with straight lines. The near future, we'll look at distance formula, which lets me do that with slant lines that are on a slant. All right, but straight lines, we can just count. And then example 4. Basically, this takes us back to algebra a little bit, which we'll use a lot in geometry. It says point B is between A and C on AC. Use the information of write an equation in terms of X and solve the equation and find AB, BC, and AC. So my suggestion, we start by drawing this out. It doesn't matter what it looks like as long as it follows these rules. B is in between A and C. So AB is 13 plus 2x. BC is 12. I don't know these are equal. I don't want to set them equal. What I know is AC is also x plus 32. So these two parts add up to that x plus 32. So 13 plus 2x plus 12 equals x plus 32. Right? So combine like terms, 2x plus 25 equals x plus 32. Subtract the 25 from both sides, and I get 7. Subtract the x from both sides, and I get x. So x is 7. Right? But it asks us to solve the equation, but it also asks us to find these. So I want to plug these back in. So this is 7 times 2 is 14. So this is 27. This is already 12. 7 here, that's 39. 12 plus 27 is equal to 39. So I am in good shape. Right? And some of you may be more comfortable showing more work here. If you're not comfortable with what I did, show the extra work. Right? We did 13 plus 12 is 25, and came down. So then I subtracted 25 here. So I have 2x plus x equals 7. Then I subtracted the x, and I got x equals 7. I did that in one thing because I can move both things at the same time. Okay? But if you're not comfortable with that, don't do that. If it helps you to show minus 25 and minus 25, show that. Okay, and that is the end of 1, 2.